Part C. Draw the structural formulae of 3 different isomers of this molecule, which show the following properties. Isomer 1 turns moist blue litmus paper red. So we are looking for isomers of this molecule. Remember the 3-hydroxypropanol that we came across, right? The 3-hydroxypropanol turns moist blue litmus paper red is a dead giveaway. What is it? It's going to be a carboxylic acid. And of course, if you look at this molecule here, C double bond O, there's a hydrogen there. All you need to do to switch that over to become a carboxylic acid, put the H over there and move the OH here. So isomer 1 turns moist blue litmus paper red. That's the propanoic acid one. And we draw that structural formula. Isomer 2 is an ester. It's easily possible to make an ester with this because there are 2 oxygen atoms there. Okay. Isomer 3 is a ketone. So we move the double bond O off the end carbon, which is when it's an alkanal or also called an aldehyde, to a carbon that's not at the end, which is a ketone then, or an alkanone. So we put that one there and we'll have the OH on that carbon there. We just swap the positions around, it will become a ketone. So it's easy to draw those, and I have discussed it before we actually look at the structures now. Okay, now look at them each row at a time, okay? First one, turns moist blue litmus paper red. That means each molecule has 2 O atoms and it's an alkanoic acid. See, what I mean is this, each molecule has got 2 O atoms there, and the fact that it turns moist blue litmus paper red, it's an alkanoic acid. So the only structure you can get for that is this one here, which, by the way, I'll tell you the systematic names as well as we go along. Propanoic acid. Propanoic acid. Okay. Now, it's an ester. The second one. If it's an ester with a total of 3 carbons, then there are 2 ways we can get this. You can have the alcohol part of the ester having 1 carbon and the alkanoic acid part having 2 carbons, which is like this second structure here. Can you see? The 2 carbon alkanoic acid bit and the 1 carbon alcohol bit in that ester. Or we could have it the other way around. The 1 carbon alkanoic acid bit and the 2 carbon alcohol bit. So there are 2 possible isomeric structures that you can get for the ester. Let's just name these as we go along. Now, the systematic name of an ester is an alkyl alkanoate, where the alkyl part of the name comes from the alcohol, the alkanoate part of the name coming from the alkanoic acid. So, look at this here. The alcohol part is the 2 carbon alcohol, which is ethanol. And the 1 carbon alkanoic acid is methanoic acid. So this will be ethyl methanoate, the systematic name of the structure above this brown dividing line. Is going to be simply ethyl alkyl alkanoate, ethyl methanoate. I'll just point out these nomenclature things as well to make sure that you see plenty of examples of this along the way. Now, then look at this next structure here. Again, remember, it's an ester. Why do I know that it's an ester? It's got a C double bond O connected to an oxygen and the rest of the things on either side. Okay, so this is also an ester. But this time, the alcohol part is the 1 carbon alcohol, which is methanol. And then the alkanoic acid part is the 2 carbon alkanoic acid, which is ethanoic acid. So it's going to be alkyl alkanoate with alkyl coming from the alcohol part. So it will be methyl ethanoate. Now, the second structure, the one below the brown dividing line, is going to be methyl ethanoate. Now, isomer 3, they said, is a ketone. So what do we know here? 3 C atom ketone with the OH on one of the other C atoms. That's what we are going to draw. This is the sort of thought process that leads us to the structure. So I've just written that here so you can remind yourself how we see that. So we have 3 carbon atoms here, look at that. And then to make it an alkanone, the C double bond O has to be not at the end. And of course with 3 carbons, there's only one way to have it not at the end, which is on the middle carbon. And then the OH will be on one of the, either of the end carbons. So the only way we can draw it here, 3 carbon with the C double bond O on the middle carbon, so it's not on the end, and then the OH group goes on as a substituent at the end.